Okay, so we are going to talk about question 42 in chapter 6. Here's the question. Specifications on a copper flush bushing are this and this. So this is the specifications. I'm going to highlight that. Okay, they are. Okay, sample of size 5 are taken every 45 minutes with the results shown in table below. Okay, so we have 15 samples, we have 5 observations in each samples. Set up an R chart and examine the process for statistical control. So we are going to go to Minitab, we are going to click on stats, we are going to go to control charts, variable subgroups, we are going to go to R, and we are going to, okay, I'm going to erase it. So before I do, actually I need to go to the data set and check how it looks like. So the data set here, okay, there are 15 of those. These are the sample numbers, these are the data sets, so they're all in one column. So after we know that, we go to control charts, variables for subgroups, we go to R, and then I'm gonna click 42 here. Okay, select this, and subgroup size is 5, so I keep it. And our options, standard deviation, don't write anything. Estimate, don't write this. These are from my past doings. Click OK. Okay, you look at the R chart, make it bigger. See, there's one point that is out of control. This is sample 12. Okay, out of this control limits. So we are gonna just write type. Okay, control limits calculated by using all 15 samples. Okay, so click OK. So I have that, I close that, and now since I have one out of control point, I want to exclude that and recalculate the control limits. Control charts, groups, R charts. So they stay the same. Our options, okay, in estimate, omit the following subgroup. I'm going to omit 12, click OK, OK, and see what happens. Okay, see, now my control limits are changed for R after excluding 12. So subgroups omitted from the calculations is 12. So this is my new control limits. So I'm going to say control limits calculated by using all by using 14 samples excluding sample 12. Yeah. Okay, so I put it away. So let's go to the question. Yes, examine the process. Yes, 12 is a problem here. So okay, what parameters would you recommend for an R chart for online control? We excluded number 12 as an answer to part B. Okay. And then in part C, estimate the standard deviation of the process. So we are going to go to, okay, so standard deviation, it's equal to R bar over D2, yeah, which is equal to R bar 7.04 divided by D2 for 5 samples, it was 2.326, I believe. Let me check. Okay, actually it should change. Okay, there's a problem here. Be careful that I want to do something, just a sec. We have to redo that. Our chart. This are options, standard deviation, okay, let's see. Excluding that, I want to show you something else. 12 and pardon, so I'm going to use the following subgroups for estimation. 15, let's see the difference between these two, because it should be okay. Okay. Sample 42. Okay, look, there's a little bit of a difference here. Okay, so the suitable way to write it is that okay, I'm gonna, before I stand actually, I want to rename it. The excluded sample 12. Okay, so subgroups used for calculations 1. Okay, so this actually gives a different result than using the other option, omit 12. Okay, be careful about that. So we are going to, so the correct one is this one, not the other one. So therefore R bar is going to be 564, not 748. One needs to be careful about that. So I go back. Okay, so I'm gonna redo my calculations. So look, subgroups omitted from the calculations is 12, subgroups used for calculations is this. So these are two different, this is gonna give you two different results. Look, R bars are different. Okay, R bars are different. So what you're gonna do, instead of you're saying omitted 12, you're gonna say use these subgroups to recalculate. Okay, so and then I'm going to have the standard deviation according to this. So R bar is not 704 anymore, it is 5.64 divided by 2, 3, yeah, and this is gonna give you what? This is gonna give you 2.42. Okay, this is our standard deviation. Okay, let's keep it because we will need that. And then in part D, they're asking about the, process capability, okay, which is CP. What is CP? Okay, question mark. Okay, so for the CP we have a formula, and also we are given the specification limits. This upper specification limit was given like that, lower specification limit was given like that, divided by sigma. Okay, 2.42 times 0.001. This is also a detail in the question. In the parentheses it said measured as deviations from this in this much. So we multiply sigma by this 0.001 inch. Okay, that's the detail. Okay, and then it's equal to 1.38. 1.38 is bigger than 1, therefore the system, the process is capable. Okay, let's do 43. So it's a continuation of the previous problem. Reconsider the data in 42 and establish X bar and R charts with appropriate trial control limits. Okay, revise these trial limits as necessary to produce a set of control charts for monitoring future production. Suppose that the new data is given in this table. So the new data, there are 10 of those. Each one has the same sample size. Of course, there are some questions where the sample size may differ. So there is a solution for that too. We don't cover in this class, but it's in our book. There are some computations for them. We don't do that. Plot these new observations on the control chart. What conclusions can you draw about process stability? Okay, so for this, so we are going to again be careful here. So first I want to send it to my Word file. Okay, and I'm gonna check my Word file. It's already here. We excluded sample 12, but we used 1 to 11 and then 13 to 15. Be careful how we write them in Minitab. Okay, so here X bar chart. Okay, let's see. So we are going to go to stat, go to control charts, go to variable subgroups, X bar R chart. Okay, all observations are in one chart, that's true. So we use 42, but we have to change our 42 sample because we have only let's say 15 of them, but we are gonna add 26 of them. Okay, let's do that. We add 43 to 42. Okay, copy cells, go down to end of 42, add those at the end. Okay, right here. Okay, control V, replace the active cell, yes. So now we modified that data set, but that's fine, we modified it. Okay, we know that X bar R chart. Okay, all observations are in one column. We are going to choose 42. Okay, okay, subgroup sizes was 5. Okay, X bar R options, estimate Okay, use the following subgroups with when estimating parameters. So we are going to say 1 to 11 again, and then 13 to 15. So this is like all the subgroups or samples 1 to 11, and then you ignore 12, and then 13 to 15. That's what it is. Okay, and it should work. Okay, so this is our let's give it a name. What is this? The title. Okay, both charts with control limits obtained after excluding sample 12. Maybe I should say it differently. Control limits obtained after excluding sample 12, but using we had first 15 data, and then afterwards we added 10 data for 25, but using 24 samples, because we had 25 but we excluded sample 12, so it makes it 24 samples. So we have that. We have the control limits that are given here, right? So if you look at this R chart first, so we have one out of control limit, which is sample 12, which we excluded before in our calculations. And let's look at X bar. We have sample 1, sample 2, sample 12, sample 13, 16, etc. So all of these are out of control limits, so it's going to show it in the test results as well. Okay, so let's go there, test results, see. Okay, so I'm going to send this to my Word so that I can follow it better there. Okay, excluding sample 12 but using 24 samples. Yeah, okay, you see that we have all these points that are failed points according to test 1. Okay, and for this we have 12, we already know, but we excluded 12. So how many points in there? 2, 4, 6. But here, be careful. Okay. Only consider points in the first 15 samples. Okay, so we have how many? 2, 4 points, which are only these guys. To track, because first 15 points we consider to build our control limits, yeah, so therefore we have 4 of those in here. Okay, out of control points. And let's see, so now we have all these 4. let's build our chart by excluding these now. Okay. Okay, so I'm going to do the same stats, go to control charts, variables, xbar r, the same data set, subgroup size is 5, xbar r options. Okay, so if you remember, we have the mean. I want to enter the mean. We can get the mean from our x-bar chart, which is 0.2, yeah. And then sigma, after excluding 12, we calculated somewhere. So 0.2 is the mean. Okay, and then this is the mean. And then standard deviation was, let's see, what was it? 242. Sigma 242. So I want to keep it in there. Okay, 0.2 and 2.42, just to be safe. And I want to estimate again this, but in this case I'm going to exclude which points? 1, 2, 3, and 12. Yeah, I mean, let's see. Yeah, pardon. 1, 2, 12, and 13. Exclude them. 1, 2. So, I mean, I'm going to exclude 1, 2, 12, and 13. So I have to use 3. Okay, I have to use 3 to 11. Okay, and then 14 to 15. Now I excluded 1, 2, and 12 and 13 because these are the problems. 12 and yeah. So click OK. Click OK. Okay, I have excluded, this is 12. Okay, I want to do one more thing. I want to keep it right now. I want to do another calculation, which is in X bar. If I don't write that, okay, let's see what will happen. Okay, so since I'm working on the control limits, I didn't include the mean and standard deviation yet. I want you to see that I have this. Okay, 1, 2 is out of control, and there's another new point that's included, and the rest are the same points. 1, 2, 3, 4, 5, and 8 points. So this tells me that I have to exclude sample 3 on top of the others as well, right? 1, 2 it was, and 12, I think it should be 12. No, this is Okay, as you see, I have 3, 4, 5, 6, 7, 8. I have 8 points to consider, so this is a lot. This is a lot. So that shows that there's this shows that the process is unstable already. Okay, so there are 8 points, 8 or 9, 3, 4, 5, 6, 7, 8. 8 points out of 15 are out of control. So this shows that the system is unstable. So one is to find the cause of that instability. Okay, so for okay, so we stop at that because too many out of control points. And here also in our chart we have all these two. What are they? 21 and 22. Let's see, what is this? 20. What is this? 23. Too many points. More than 8 actually. More than 8. 3, 4, 5, 6, 7, 8. And also here new number 9. 21 is also 22. Too many points are out of control. So the process is unstable. So yeah, that's the end of the question. We are gonna say, give it a name, title. Okay, control limits after excluding 1, 2, 1 to 12 and 13. Yeah, 12 and 13. Okay, so I'm gonna copy this. Send to Word. Okay, so I'm gonna say actually it copied somewhere else, so be careful about that. Your cursor needs to be, so I'm gonna redo that. Okay, I'm gonna resend it. To Word. And I'm gonna say okay, there are where's the list, actual list of test results? See, I have I'm gonna only consider actually the first 5 of them here, and then R chart 12. Okay, that I'm interested in. Okay, too many. So there is in total 2, 4, 5. Okay, I'm gonna say there are 5 points which are 1, 2, 3, 12 and 13 are out of control. Okay, so I have to look at the first 15. Just look at first 15 samples. Okay, so there are 5, so I can still go try one more time then, because this 5 is not still as big. So let's do it one more time. Okay, control charts, X bar R. So I'm gonna exclude now, including 3. Okay, so I'm gonna estimate, I'm gonna exclude 3 as well, so I'm gonna start from 4. Okay, let's see. Okay, let's get this chart again. Okay, 1, 2, 3. Okay, I knew that the first 3 is out of control. What is this? Sample 16. Oh, okay, this is not, I'm not interested in this part. I'm interested in the first 15. Okay, I have data sample 12 and 13 is in here. Let's get the R chart. Sample 12 and sample 14. So there's one more that's included to the list. Okay, so I'm going to give this a name. Okay, add title. So control limits updated after excluding 3 as well. Okay, so 3 as well. Let's send this test to the Word. Okay, the test results. Let's get the test results. I want to just first look at the first 15. I'm gonna highlight that. The first 15. Okay, so I'm gonna say after excluding 3, then we have samples are out of control. Out of 15, 6 okay, 6 out of 15, 6 samples out of 15 samples is a lot and shows the sign of process instability. So one needs to find the cause of the instability. Okay, and we stop at that. This is a lot. Okay, save that. In 43, I mean this was 43A, and then let's get 43B. 43B. Okay, 43B. Use all 25 observations to revise the control limits for the X-bar and R charts. What conclusions can you draw now about the process? Let's see. Okay, so we are going to go to stat again. Control charts, subgroups, X-bar R charts. Okay, the same data, X-bar R options, estimate. We are going to say 1 to 25. Yeah, we have 25 data. Okay. So let's see the X-bar chart. Okay. So out of control limits, there's sample 1, sample 12, sample 13, sample 16, okay, sample 17, also here sample 12. Okay, so we are gonna give it a name. Okay, control limits after using all 25 samples. Okay, keep that. So let me send this result, I mean not this but this. Okay, send this all to the Word and see what happens in the Word. Okay, so let's get the test results. So I have these all. Now since I'm considering first 25, I don't consider on the first 15 anymore. And for our chart I have that, so I'm gonna say, okay, at the end I'm gonna say according to the calculations done by using all 25 samples, we have out of control limits, control points, nor samples. Okay, so let's remove them. Let's remove them and recalculate the control limits. Okay. So I'm gonna go to control charts, variables, X-bar S, X-bar R, X-bar options. Okay, I'm gonna estimate. So I'm going to exclude 1, 12, 13, 16 and 17. So I want this to start with 2. 2 goes to 11. Okay, and I'm gonna start, and 14 to 15, sorry, 15 is fine, 16 we exclude, 17 we exclude, so 18 to 25. Okay, so when we do that, we get that chart. Okay, so let's type the name. We excluded samples 1, 12, 13, 16, 17, right? Okay. Yeah. Okay. Okay. Let's get the test results. Send this to the Word. So we look at the test results. We look at the test 1 results. Okay, here. Okay, this is for X-bar and this is for our chart. We have one more, right? We have his out of control points. Out of control points. So so let's remove the 20 as well. Okay. Again, redo that. Charts. X-bar R. Exclude 20 as well. So I'm gonna go to estimate. 20. So I'm gonna go to 19 and then 21 to 25. So let's compute it again. Okay, make it bigger, type the name, title, we excluded all of these, yeah, click OK, and then let's get the test results. Okay, stamp the word. Okay, let's get the word. Okay, we have more and more points, right? According to test 1. Number 18 is also included this time. Okay. Are out of control limits. Okay. Out of control points. 2, 4, 6, 7. 7 points out of 25 points is a lot. System is unstable. Or system or process. Okay, so source of deviation. Need to be identified and removed. Okay, that's the end of the question.